All right, physics, this is your video here to get you a little help on understanding Newton's second law of motion. So Newton's second law of motion is that there's a net force acting on an object, and that net force is going to cause that mass to accelerate. Now what that means is that as long as we see acceleration acting on an object, then we know that there's a net force. Now a net force is really just meaning that the forces are not balanced. So when we see no balance on our forces, that means that there's a net force and we're going to accelerate in the direction that that unbalanced force is acting. Now I want to just do this. This is a math relationship, so I know that I want you to understand those math relationships. So we're just going to put this into a triangle as well. Mass is going to go here, acceleration is going to go here, and our net force is going to go there. Now the net force is going to always be measured in newtons. So again, this is going to be in a newton. The mass is going to be in a kilogram. And the acceleration is going to be in meters per second squared. Or we can write this as meters per second per second. Okay, so those are the values, or I should say the units to these quantities, and this is the way that we kind of set this up. So again, if we want to find the mass of the object, it's the net force divided by the acceleration. If we want to find the acceleration of the object, it's the net force divided by the mass. If we want to find the net force, we take the mass times the acceleration. And remember, we're looking for unbalanced situations, or where the forces are not going to balance. Now, you should have a little Ziploc bag that has the second law in it. We're going to kind of work with this here, and we'll work together a little bit. So we're going to start with the cards. Okay, so these cards represent kind of free body diagrams, and we're just going to kind of sort them out first and see if we can find out which ones are moving and which ones are not moving. So I want to know, based on what we have here, which one would be moving in the positive direction. So we want to find one that's going to be moving in the positive direction. Now I see this one right here. This is one that's going to be moving in the positive direction because we have 2 newtons acting this way. It's not balanced, and so that mass is going to accelerate in that direction. So that's one that's accelerating to that way. Let's look at this one right here. Here's one. This one is free body diagram D, and you can see that this one now has an arrow that's pointing this way. So this is accelerating, but it's accelerating in the negative direction. So we're going to have that one accelerating in the negative direction. Now I also have one here. This one is G, and this one has 0 arrows pointing on it. So in other words, this is one that would be a balanced situation. So there's 0 acceleration, because if the net force is 0, then you'd have to have 0 acceleration. So we've got acceleration this way, and no acceleration. Now, I've got a bunch of other ones here. I'm just going to set these aside. Okay. And let's look at some of these other ones. So I've got 1, 2, 3, 4, 5. All right, let's get a little bit more room here. Okay, so you guys can see these are the remaining ones that are in here. I want to make sure that I've got them all turned the right way. So we're looking for ones that are going to accelerate to the positive direction, or accelerate in the negative direction, or not accelerate at all. So let's look at this one right here. You can see that this one has 3 newtons going this way, 1 newton going this way. So the net force is going to be the difference between these, because this is positive 3, this is a negative 1, and the difference between them will be positive 2. So this has 2 newtons of acceleration in this direction. So this one's going this way. Now if we look at like this one here, okay, this one has 3 newtons going in the negative direction, 2 newtons going in the positive direction. the net result would be a -1 Newton, because it's the difference between those two. So this one accelerates this way. Now let's see what else we got. Okay, I see that here's one with arrows going both this way. So we've got 3 newtons going this way, we've got 1 Newton going this way, so really this is going to be 4 newtons in the negative direction. Okay, so that's going to give us acceleration this way. And here we've got 2 arrows that are both pointed in the same positive direction. So this would be 3 newtons this way and 1 Newton this way. So we now have 4 newtons going this direction. And this one here, we're down to just 2 more. These are both newtons that are pointed in that negative direction. So -2 and a -2 would give us a -4 newtons in this direction. That cause acceleration to go this way. And then we got this last one. So we've got 2 newtons going this way, 2 newtons going this way. So +2, -2, they're going to cancel each other out. And so this one is a balanced situation, 0 acceleration. All right, we're going to start with part 2 now of this, which is going to be on motion maps. So a motion map, again, tells us about what's happening. It's kind of like the tape timers that we had in the other activities. So if you see things like the dots that we're forming, and we see the dots getting bigger and bigger, okay, we know that that means that we are accelerating. If we see that the dots, and I should say accelerating in the positive direction. So what happens here is the motion is getting bigger each time, so our displacement is changing. Okay, and so this shows us that we have positive acceleration. Now if we had a set of dots that did something different, so like let's say we have a set of dots, maybe we're already moving, so this could be already moving. But now our motion is getting smaller. Okay, we could see this as maybe a negative acceleration, so we know that we're slowing down. So this is the kind of way that we look at motion maps. Now you have a bunch of motion maps in that same bag, so I'm just going to take out these motion maps, and we'll need to kind of straighten them out a little bit, but we're going to sort them as well. We're going to put them into a couple of piles so we know whether we have motion that's going in the positive direction or motion that's going in the negative direction. So I'm just going to run through these. I see that I've got all my arrows pointed in this direction, so that's a -1. And I see here I have motion that's going in the negative direction. Here I have motion that's going in the positive direction. Okay. Here I have motion that's going in the negative direction. This is positive direction. This is a positive direction. This is a positive direction. And this is a positive direction. So we've got a bunch of ones that are going in the positive direction. So let's just go through some of these. I'm going to slide this up here so we can have more room to look at them. So I've got these ones that were all moving in the positive direction. Okay. And so let's do this. I'm going to pause it a second and raise this. Okay, that's a little bit better, but I wanted to kind of look at all of them at the same time to kind of see what happens here. Now, if we're looking for like acceleration in the positive direction, we want to see if we've got ones where the arrows are getting bigger and bigger. So like this one, the arrow is getting bigger and bigger and bigger. So this is definitely some acceleration. So I'm going to set this one over here as an acceleration one. And let's see, I see this one here. This has an arrow where the arrows got bigger, so that one is also some positive acceleration. Now in this one here, the arrows were getting smaller, so this is going to be that negative acceleration. We're moving this way, but we're slowing down. Okay, and then this one again would be one, the arrow got smaller, but we were moving this way and slowing down. Now, if we start to look at the last one said we're moving in this direction, but all the arrows look like they're the same size. So this would represent constant motion. So that would be a constant motion. Okay. I want to go back to these two. And if we looked at this, we probably started slow and we're getting faster and faster. Here we were moving faster, and then we even got faster yet. So again, little difference between these two. They're both accelerating, but this one had more velocity at the beginning than this one did. Now we probably see the same thing here. We were moving faster here because there's more gap there, and then we're slowing down. Here we were moving a little slower, but then we're slowing down even more. So there's a little bit of a difference between those, but I just wanted to show the differences between all those motion maps. Let's go back to these ones that were pointed in the negative direction, and let's see if we can kind of understand these. It looks like, let's see, this one is definitely, we started with a small arrow getting bigger, 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 so we're accelerating in the negative direction. So we're getting faster and faster and faster, but we're going in this direction, so we're kind of going in the backwards direction. That's the way I interpret that one. Let's look at these next two. Okay, so now like this one here, we have like an arrow that was getting bigger, and we got to this biggest point here, but then we started to slow down. So if we think about what was happening here, we started to speed up, but then we had to slow down. So this one shows a changing motion, but all of it happening in the same direction. So we had something that was accelerating to get to here, okay, so speeding up through here, but then through this range we were slowing back down, so we were changing our speeds. That's a very interesting one. And then the last one here, if we look at what's going on here, these arrows all look like they were the same size. So really we had constant motion through here. So it was traveling with a constant speed, but then at the end it ended up changing its motion. So it changed between here and here, and now we have some more constant motion. So it was like it was driving along at a constant speed, we accelerated all of a sudden, and now we're going again at a constant speed. So those are the motion maps that you have, and hopefully you get a little bit of an understanding of how they look, and now you can move on to some more questions.